Hi everyone, welcome back. So this time I'm actually going to take you through a truss problem, do the entire thing with you, and you're like, oh wait, no PowerPoint. Yes. I'm just going to write it all down this time. You'll still be seeing PowerPoint examples, but I'm taking some from the book so you can have extra examples of these more basic concepts. Now, we have a truss here we want to solve for these internal forces. To do that, how are we going to do it? Well, we're going to first solve for our reaction forces by making a free body diagram. So I'm going to go ahead and replace this pin support with one force going up, one force going to the right. I always draw them in the positive direction. Now, if you're sentient or if you're omniscient, you can figure out exactly what direction they're supposed to go. And then I'm going to draw one straight up here. I need to name these, so I'll call this force C, this force A vertical, this force A horizontal. A lot of times I use X and Y. This time I'm just using horizontal and vertical just to give you another perspective. Now I have three equations. I have some of the forces in the X, some of the forces in the Y, and some of the moments about a particular point. So which one I use will change my answer. So which one am I going to use? You know what I'm going to do? I'm going to do some forces in the X first. And you know why? Because it's going to be easy. There's only one force that points in the X direction, except for my unknown. So if I write it out, it looks something like this. Now that's pretty simple to solve. Don't even need my calculator for that. What does this tell us? Well, at first it tells us that we drew force AH in the wrong direction. So I would want to flip that around. I don't have to, but for these it's usually better. Okay. So 5 in that direction. Now I've got two more unknowns and I've got two more equations. Now the second equation I usually go to is never forces Y, it's almost always at some of the moments, because usually I'm able to get rid of one of those unknowns if I do that. Force in the Y, I would actually just have an equation and I have to use the information I got from some moments to solve it. So some of the moments first, and I'll do it about point A, just because that's where I usually do it, because there were two unknowns there, but now there's only one. So some moments about point A is going to be equal to, well, let's see what we have here working for us. Well, we have this guy, okay, and that is clockwise. I always consider clockwise negative. Then we have this guy, also clockwise, also negative, and we have this guy. And I'll be honest with you, this works almost every single time. The only way it does not work is if you are being silly and you try to wrap around, okay? That messes you up. But if you don't try to be silly, this is a good way to figure out what direction it's turning. So now let me put these in my moment. Remember, I don't care about what direction the forces are pointing or what direction distance it is away. None of those matter. All I care about is the clockwise or counterclockwise when it comes to negatives and positives. So what I have here is 5, and that's a horizontal force, times 10. That's negative. And I've got 10, that's a vertical force, times a distance of 8. And then I have 24 times force C. That's all going to be equal to 0. All equal to 0. Now I want to solve for force C, so I get force C is equal to 130 divided by 24. If I plug that into my calculator, I get, let's see, 130 divided by 24. 5.416. Okay, so that's good. I'll go ahead and erase that. I'll also clean up a little bit because all these crazy curvy lines do make it harder to read. Now I have one last unknown, which is force AV, and I have one last equation which I haven't used. You can also do some moments a second time if you wish, Sometimes that makes things easier. But I'm going to do some of the forces in the y direction. I like that one. So, some of the forces in the y direction, what do I have? Well, I've got 10 kips pointing down. And then I have my force C pointing up. And then I have my force AV. And if I solve, I get force AV is going to be equal to 4.584. Okay, so that worked out fairly well. 4.584. So now we need to go to the internal forces. So with that, I'm going to erase everything over here. So if you haven't copied all this down, or if you need more time, make sure you pause the video now. Okay, and it's all disappearing. Gone. So we want to calculate the internal forces. So we're going to pick a point, C, A, or B, to make a free body diagram of, and then calculate the forces for the members in that part. Either A or C, it seems to me, it would be giving you the same information. B is going to be a little bit harder because there's no member that points along an axis. I really like when I have a member that points along an axis because it does simplify things, as you're going to see. So I would choose C or A. I'm going to choose C just because it looks simpler to me. So I'm going to redraw a free body diagram of that point. Okay. I always draw my forces pointing away if I don't know what their direction is. Because if I got it wrong and that was actually supposed to be the opposite direction, then I know it's in compression. Drawing the arrow pointing away, if you get a positive number, it's in tension. If you get a negative number, it's in compression. And I'll name them. So this will be force AC, it's force BC. And the last thing I'll need is to have a slope triangle for this one right here. So I know it rises 10 and it runs 16. So both of those are divisible by 2, so we go ahead and simplify that to be 5 and 8. And so what is the hypotenuse then? 25 plus 64. Take the square root of that, and it comes up to 9.433. Okay. 9.43. Next thing I might want to do is break my force BC into components. So I'm going to pull it aside, and I'm going to solve for each of those components. Okay. Force BC horizontal, force BC vertical, and you know what? I've kind of... Nope, everything should be good here. Just didn't draw to scale. So, with this right here, I'm going to go ahead and solve for both of those side ones in terms of force BC. So force BC horizontal will equal to force BC times the horizontal component of my slope triangle over the hypotenuse. So 8 over 9.43. And then force BC vertical is going to be equal to force BC times the vertical component of my slope triangle over the hypotenuse. So 5 over 9.43. And now I can just forget that force BC exists, and I can put it all in terms of the horizontal and vertical components. Now if you look at this, only force BC has a vertical component. And there's only one other force in the vertical direction, which means that we can use our sum of the forces in the y direction or the vertical direction, if you want to temper it, to solve for force BC. So I'll do that. So sum of the forces in the y is going to be equal to 0, be equal to 5.416 plus force BC times 5 over 9.43. Oh my. That's a bad spot on my surface apparently. It's supposed to be 9.43. There you go. Now what you're first going to see is that, well, both of them are adding, so it means that I had force BC in the wrong direction. So force BC is going to be equal to And let's see. 5.416 times 9.43 divided by 5. I think I did all those numbers right. I did. Comes out to 10.214. And that will be negative, which means that it's in compression. Now, using that, I can solve for force AC. I'll do my other equation. I only have two. Some forces in the y and some forces in the x. That equals 0. That's going to be equal to the horizontal component right here, which will be negative 10.21 times 8 over 9.43. Now it's pointing in the negative direction, so I should already make it positive. And then I would subtract from that force AC. Now be very careful here. So it's pointing in the negative direction, and it is a negative number, so they cancel out in this case. It might seem kind of weird. If you want to, you could have reversed your arrow just to make things a bit simpler on yourself. And so now I solve for force AC. And that's going to be equal to 10.21 times 8, and then divided by 9.43. 8.661. Okay, 8.661. And that'll be in tension because it's positive. Now I have this force, I need this one over here. So I'll go to the point A because, once again, I don't want to mess around with those angles. This looks like a pain. So we'll go over to point A. I'll redraw it again. I have a different slope triangle this time. So this one right here is going to be 4, that will be 5, and then I have to solve for the hypotenuse. So let me do that. Four times 4 plus 25. And I'll take that to the square root. I get 6.403. Okay. So this will be 6.403. And now to name everything. So this is force AB. This force over here I've already solved for, and that would be 8.661. And if you're wondering, well, isn't it pointing the wrong direction because it was pointing to the left over here? It is always pointing the opposite direction when you go to the opposite end of it. Just, it's in tension, so it should be pointing away from this little dot. That's the important thing. I've got 5 keeps going this direction, and I have, quite the wrong direction. .584 going up. So lots of forces, but the thing to remember is that force AB is only going the vertical direction, so I only need my one equation, which is the sum of the forces in the y direction. That equals 0. That'll be equal to force AB times its vertical component, which is going to be 5 over 6.413. And that will be plus 4.584. So as you might be guessing here, this is telling me that I drew force AB in the wrong direction as well. Okay, drew that in the wrong direction as well. So I'm going to solve for this, and what do I get? 4.584. That will be times 6.413 divided by 5. It'll be 5.879. Okay. So force AB is equal to negative 5.879, which tells me it's in compression. And that's it. I have solved for everything. So I have force AB right here. I have force BC right here. And I have force AC right here. And technically, if I gave the C's and the T's, I would usually drop my sign. But I'm leaving the negative sign right now just in case you're working a problem, because normally I say compression is negative in your problems, and you'll need to keep that negative sign. Well, I hope this helps you. I know this was a very long video because solving these problems by hand takes time. But hopefully seeing it worked out helps you and you can get a better idea of how to do it in the future. Thanks for listening, and I'll see you all next time. Bye-bye.